So good morning, everyone, and welcome again. So I hope काल मी जास्त बोर नसेल केलं तुम्हाला आणि ऍटलिस्ट त्यातून काहीतरी तुम्हाला भेटलं असेल नवीन.
हो सर, नक्कीच.
Okay, so
Sure, sir.
so tomorrow what we will do here is that I'll give you an introduction on how we perform targeted quantification. So say for example, uh, you are doing an experiment, and in that experiment, from literature or from literature and previous studies, you know that there are certain molecules which are either increased or decreased, but you want to quantify how much that particular molecule is increased in terms of uh, absolute unit like nanograms per mil, or in macromolar concentration. So this is what exactly we will do here. Uh, and as we go along, I'll try to explain everything to you. Okay, so the basic definition of target quantification is kind of an overarching umbrella term for mass spectrometric methods. And we try to quantify or measure the accurate level or amount of that predefined molecule. And that molecule could be either a protein, it could be a peptide, it could be a small molecule like metabolite, or a lipid, or any drug, or its drug product. It could be anything, or even an antibiotic, even a pesticide. We can measure anything using this technique. So, in order to perform a classical targeted measurement of any small molecule or any analyte, so there are two things we should know. We should know what is the molecule we are looking for, number one. Second thing, we should know how they behave in a chromatographic uh, system. That means we should know at what time they are eluted on the column and what time we can detect them. And as well as we need to know what is their mass. Okay, so if you have this at least two information, that their mass and a tentative uh, time, at a tentative idea of what time we can see them. If we have these two parameters, then we can detect them and quantify them. So the chromatographic small molecule quantification or quantification of any molecule using mass spectrometry, it's basically is that we do we when we know the accurate mass of any molecule and the retention time, so we use that information to acquire the data across multiple samples for multiple molecules or multiple analyte. And what we do there is that if you look at this particular figure, so you will see that there is a graph here. On x-axis it's a time, and
Sir,
y-axis
excuse
it's
me,
in.
the screen is not
Yeah.
yet shared.
Oh, I'm sorry. I'm terribly sorry. Okay, maybe we'll start from beginning.
पार्टिसिपेंट्स आपको भी नहीं दिख रहा है ना कि मेरे तरफ से कुछ इश्यू है?
नहीं मैडम
नहीं नहीं
दिख
नहीं,
रही
आई थिंक
नहीं
मैंने
नहीं
शेयर ही
मैडम
नहीं किया था.
दिख रहा है
ओके
नहीं नहीं नहीं,
ओके
मैंने शेयर ही नहीं किया था. आई एम
ओके
सॉरी.
ओके
ओके
Okay,
ओके
यस सर, नाउ इट इज विजिबल.
okay. So maybe we'll start from first slide. Okay. So as you can see here, so this targeted quantification, this is a kind of an umbrella term in the world of mass spectrometry, and the overarching idea for this method is that we try to quantify any molecule of interest. That molecule could be any protein, it could be any peptide, it could be any small molecule like amino acid, it could be a sugar. Uh, are you guys, everyone hearing me clearly?
Yes sir.
Yes
यस
sir,
sir.
yes sir.
Good, good, good.
Yes.
Okay, it could be a metabolite or it could be a lipid. And in order to perform a targeted measurement, we need to have some idea about what molecule we are trying to measure. Number one, we also need to know what is their chromatographic behavior. Say, for example, what kind of solvent it required to get it dissolved, number one. What kind of solvent will be where it is not dissolved very clearly so that we can use that solvent to elute it out. Okay. And number three, we need to know what is its mass. So if we have these two or three piece of information, we can use that information to measure this molecule in absolute quantities. Say, for example, in nanograms per mil or micrograms per mil, or in molar concentration such as millimolar or nanomolar. Okay. So, so what we actually do is that once we have those information like the retention time and the mass, then we can take all our samples and acquire the data over multiple samples. And what we are looking for is that if you look at this figure here on the right hand side, so what we have in right hand side, there is a typical chromatographic peak where we have time on the x-axis and intensity on the y-axis, and the whole area under this curve, this area this area correspond to the quantity of that molecule in that mixture. So say, for example, if a particular molecule is at very higher concentration, you will see that this peak will very high. If it's in lower concentration, the peak will be lower. So based on that, then we can determine its concentration. Okay, so the question is how the targeted data is acquired. So you can see here, this is a typical anatomy of a mass spectrometer. So what we are doing here is that we are injecting our mixture of molecules, or either it could be a mixture of molecule, or it could be an extract from plant or extract from a leaf, or it could be extract from E. coli or in bacteria or any tissue, or it could be a saliva, it could be uh, wash from a soil, it could be anything. And all these samples which I've told you now has contains lot of different molecules. Sometimes it could be bacterial secretion and hormones and all those things. So when we inject these molecules in the mass spec, so you can see here there are four rod-like structures. So these are called as poles, and these pole actually in, uh, produce electric field, and it vibrates those molecules under the electric field and magnetic field, and basically it directs this molecule through this area, and whenever we specify, direct these molecules, and finally we can detect this molecule in term as the peaks. Okay, so this is something called as uh, s- uh, full scan scanning. So you detect all of them together, but in this case we want to target only few molecules which are of interest to us. So in this situation, what happened is that in the Q1 quadruple, you can see here in Q1 quadruple, we have a gate, and this gate will allow only those molecules whose mass we will specify that we want to detect these molecules only. So say, for example, if you want to detect 436, 562, and 879, so it will sequentially only allow this mass to go through this filter. So now once we have this mass go through this filter in the collision chamber, so this second chamber is called the collision chamber, where uh, we impart a high energy, we impart high energy, and under an inert gas such as either nitrogen or helium, then we break that molecule into small fragments. Okay, and then we collect that data as a MSMS data or tandem MS data. Okay, so this is how we can focus our molecule of interest or mass of interest, and then we fragment it. Another real life example I can show you here. This is an MS1 scan, which is shown here on the first panel, where we take all the molecules and then we allow all the molecules to go through our Q1 chamber, and then we detect their masses in the orbit trap or in the time of flight, and then we record that masses as a spectra. In the second panel here, what it's shown is that we allowed only one mass which has one precursor which has a mass of 116, and then we fragment that mass using energy. So what happened is that that 116 mass is fragmented into two part. Some part of the precursor ion is still intact, whereas some portion of the precursor ion which is fragmented, which generate a major peak or major fragment which has a mass of 70. So we can use this mass to quantify and identify our molecule. So, okay. So in the present experiment, which we will do as an dry lab exercise. So the data which you're going to work on is acquired on an Orbitrap IDX mass spectrometer, where we will try to measure the absolute abundance of amino acids using an external standard. Okay, so the experiment was very simple. In this experiment, Arabidopsis leaves were treated with either water, which is a mock treatment, or a toxin, which is named as a drug X, which is isolated from a bacteria of Pseudomonas syringae. So Pseudomonas syringae is a bacteria which has lot of implications in plant root and bacterial interaction, and it produces certain toxins which which inhibits the plant growth, and that's why there is interest in studying these toxins from this particular bacteria. So what exactly this toxin do is that this toxin cause the tomato to reopen. Normally what happen as a defense response whenever a pathogen attack a plant, because plant do not because it's a stationary entity, it has its own mechanism, it has its own defense mechanism to counteract that attack, and closing of the stomata is one of those defense mechanism. Okay, so it close its stomata and try to conserve all the moisture and all the energy. But what this toxin do is that it causes the stomata to reopen, and because of that this toxin can manipulate the hormone signaling of the plant, and it can give access it can access the nutrients and other and disable all the defense responses from the plant. So what uh, is being done in this experiment is that the leaves are sprayed either with this mock solution or water, or the toxin, which is dissolved in some part of water and then sprayed using uh, a, a, a phytological treatment. Okay, and then after 24 hours, using a thin needle, we collect the sap from the leaf. Okay, and then we try to detect, or we try to understand how the toxin has effect on the metabolism, and to understand that we are measuring all the 20 amino acids in this experiment. Okay, so once the sap is collected, because as you have seen, might have seen, Arabidopsis plant is a very small plant. So to take a needle and insert it into the its main vein and remove the sap, which is barely maybe 20, 10, 20, or 30 microliter of volume. So that's only you get from each leaf, or maybe from multiple leaf. Okay, and after that, once we have that leaf sap, then we extract the leaf sap using methanol chloroform extraction. So whenever we use methanol and chloroform for extraction, what and then we add water to it, so what would happen is that it will create a biphasic system. So you will have a top layer which contains methanol and water uh, uh, part, and the lower part will have your chloroform phase. So we collect the top phase, which is a aqueous methanolic phase, and then as a mixture of uh, small molecules. We dry that mixture in a speed vac or under a stream of nitrogen, and then we put it back in a in 100 microliter of water containing 0.1% of formic acid. So the reason why we add formic acid is that it it change the pH of that solvent to the acidic phase, and it imparts a hydrogen ion to all the molecules. That's what we call a protonation. Okay, so how so whenever we do any quantification, so there are two strategies to do quantification. So one is called as internal spiking of internal standard. So actually, this method of spiking of internal standard is considered as a gold standard method where it has been approved by all the major agencies all over the world, like FDA and all those agencies, and they want to see that every experiment should be done using a heavy label standard. So what we actually do is that we add a known amount of the molecule which you want to detect. Say, for example, in this case, you want to detect asparagine. Okay, so you take a normal, we want to take the quantity of normal asparagine. So to detect that, we add a known amount of heavy labeled asparagine. Heavy labeled means if you see this asparagine structure, I have labeled all those carbons as carbon and nitrogen as 1, 2, 3, 4, 5, 6. Okay, so what has been done here is that all the four carbons from 1, 2, 3, 4. So normal in normal condition, all the carbons are a natural carbon which has 12 atoms. Okay, whereas in the heavy, these are labeled. There is one. These carbons are labeled with heavy carbon. Okay, and also the nitrogen. The two nitrogen are also labeled with heavy nitrogen, not 14N but 15N. So overall, we increase the mass of that molecule, which was ideally should be 133. Now we have a mass of 139. But irrespective of the change in mass, the chromatographic behavior of this molecule, both of these molecules are same, and you can see here that both of the molecules they elute at the same, almost at the same time, like 1.3 minutes. So this is a very important feature in this sense because you can see here that whenever we fragment a normal asparagine, we get a fragmentation pattern where we have fragment like 133, which is the parent ion, then we have 116, 87, and 74. So I'll come to this part how we can get this fragmentation pattern. So you can see here we get this fragmentation pattern of different fragments, and correspondingly we also get same kind of fragmentation pattern from the heavy labeled molecule as well. And if you look at here, there is a mass difference which is kind of similar in these two major peaks. So in the light version we have a 74, in the heavy version we have 77, which means that this fragment, the number of carbon or nitrogen atom present in this fragment are same here as well. Only difference is that they are labeled with 13C. That's why they have higher mass. Okay, and finally, when we want to determine concentration of this unknown asparagine from our sample, so what we do here is that we take the peak area of the light version of this molecule, divide that by the peak area of the heavy version, and multiply by the concentration which we know how much we have spiked in there. And that will give you absolute quantification of that molecule from your mixture or from your complex matrix. So this is how the ASN or asparagine is fragmented. So If you see here, this 133 is the parent ion or the precursor ion. So this particular 133 represent the mass of the whole molecule plus a hydrogen ion. Okay. So and whenever this molecule fragment inside a mass spectrometer, so there is a huge, all the carbon atoms which are connected to each other are very stable as compared to the bond between carbon and a non-carbon atom. So say for example, here we have a, a bond here between carbon and this ammonia. So this bond is very susceptible to break very easily. Even if we give a little bit of energy, it will break, it will just fall off. So what happens whenever this particular ammonia is lost, we the remaining part of this whole molecule has a mass of 116. So that's the 116 peak we are getting here. From this remaining molecule, if we lose a carboxyl group like this one, if we lose this carboxyl group, then we get a mass which is equivalent to 88. Again, from the whole mass or the whole molecule, if we lose a water molecule and a carboxyl group, maybe this part, water molecule and a carboxyl group, whereas this part, the whole part will be intact. Okay, so we will get a major peak which is 87. And again, from this 115, 116, if we lose a methoxyketone group, we'll get a major peak which is 74. So this is how the fragmentation works. And based on the fragmentation pattern, even say for example, if we don't know the exact molecular formula of an unknown molecule, based on the fragmentation pattern, we can deduce the molecular formula and we can try to identify that molecule. Okay, so that was one of the strategy to quantify your molecule of interest by using a heavy label internal standard spike. So that heavy label internal standard could be labeled with either 13C carbon or a combination of 13C and 15N, or it could be labeled with deuterated hydrogen. And there is a second strategy to do that is to generate an external standard calibration curve. So say for example, you want to detect a quantity of this particular amino acid, asparagine. So what you have to do is that make a mixture of different concentration of the standard, maybe 100 micromolar to zero point 0.5 micromolar, and then we generate a standard a calibration curve, and using the intercept and the slope, we can calculate how much is present in an unknown sample. Okay, so in today's exercise, we will use this external standard calibration curve to quantify our molecule of interest from our mixture. Okay, so I think that's all I have to talk. Now we can actually start with our tutorial. Okay, so I think I have provided you a zip file which has targeted metabolic quantification zip, and I hope everyone has unzipped that file, and it should contain some Excel sheets and some raw files. Okay, so keep that handy, and I hope everyone has already downloaded this Skyline software. So we'll start with that now. So once you open the Skyline, so this Skyline is although it looks very simple, but it's a very complex piece of software, and it has a lot of functionality. It can work with proteins, it can work with small molecules. So the first thing we need to do for this exercise is to change the setting. Just go to right hand side top corner and change it to molecule interface. Okay, and then once we finish that, go to the file menu and start a new blank document. Okay. Does anyone have any problem till now?
Sir, we have to do this simultaneously.
Yeah, I mean, as I'm going along, either you can try it, or I can give you time, and we can go along together.
Okay.
Sir, excuse me,
Hello.
can you start from
Hmm.
first step?
Sir,
Okay. Yeah,
start
yeah.
it
So,
again, sir. Start it again, sir.
okay, okay. So everyone has this software installed, I presume. So open the software first. Once the software is open, then just let me know. Maybe we'll wait for like 2 more minutes, then we can go to the next slide. Okay, so the next step in that process is that once you open your software, go to right hand side. You will see a small icon here. So click that icon. It's a kind of drop down menu and select molecule interface. Okay, everyone done with that part? Can you move to the next slide?
Yes, sir.
Okay, so then go to the menu item and click setting. Hmm, hang on a second. Okay, so go to the menu item, menu, settings, and click transition settings. Okay, so there are few tabs here. So forget about the first tab, go to the second tab, which is labeled as filter, and make sure that you add or you can add different adducts using this arrow. So click that arrow and then select M plus H in brace brackets. In the precursor adduct, select M plus H. In the fragment adduct, select M plus. And in ion type, select or you can type in F small letters and P small letters. So the F and P represent fragment and precursor.
Sir, F and P.
Yes, F and P.
So is it F dot P or FP only?
No, F comma P.
Yes. Okay.
Okay. Then go to the next tab, which is instrument tab. So in the instrument tab, we are trying to define a range of the instrument in terms of molecular mass. As we know, all the amino acids are mostly start from maybe 70, 75 to 230 or something. But we will give a wider window. So you can write 50 and 1500. So this is a quite big range, and I think all kind of molecule can be accommodated within that range. Okay, so if it's not selected automatically, normally you will get all these settings automatically there. If it's not there, then you can write it down 50 and 1500. Okay, and then go to the next tab, which is called as full scan. When you go to full scan, there is an option drop down menu called as MS1 filtering. Click that and select count, and in the precursor mass analyzer select as orbit wrap. It will automatically select 3 peaks. If it's not, then you can type in 3 there, and the resolving power as 60,000 at 400 mass per charge ratio. Okay, and then come down to the MS filtering. So I think these slides I have made, it was maybe in the older version. So that time they have something called as targeted. In your version, either you might get targeted or you might get something called as PRM. So if you don't have targeted, then select PRM. And again, the mass analyzer select as an orbit wrap. And the resolving power now select as a 30,000 and 200. And then click OK. So this is the setting we have to set so that our molecule can be detected in the experiment. Okay, should we move to the next slide?
So should we
Sir,
select
what
all
that
all
three
the
ions?
or
Hello, sir.
I'll tell you
If
what the
it
3 ions
if
are.
it
So
if it look if it is 3 ions, then what we are doing? 3
which
ions.
3 peaks? You mean to say these 3 peaks? This one?
3 peaks? Okay.
Yeah, so 3 peaks means uh, I'll tell you what this represents. So whenever we have isotopic distribution of any molecule, so you will get uh, 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 an M plus 0 ion, which is the highest intensity, and then we get uh, uh, the 13C M plus 1 and M plus 2 ions, which are not very abundant naturally. So that's these 3 represent at least 3 minimum peaks. Okay.
Sir, what's the next step? Then we have to click on OK.
Yeah, so once you finish with the MS filtering and orbit wrap and all these settings, then click OK.
Okay, sir.
Okay, so we'll move to the next slide. Okay, so I think in the same folder, I have provided something called as Skyline amino acid transition.csv file. So you can open that file in your Excel. So once you open that file, you will see that there are bunch of information provided there. We have a molecule a column called a molecule list name. We have a column called a precursor name. So precursor name correspond to all the amino acid we want to detect in our experiment. And then we use their molecular formula. And since we are detecting these molecules in positive ionization mode, which means that uh, these molecules will be protonated. That means an additional hydrogen atom will be attached to this molecule. That's why the M is the original mass of the molecule, and then we are adding an additional hydrogen to it. Okay, so that's what is represented here as M plus H. Okay, and since we are detecting this molecule in a positive ion mode, so the charge on the ion will be just 1. Okay, so this file is already provided. make sure that you have that file and you can open it and see the information. And then what you have to do is that just select all those columns, Control A and Control C. You can just select this column and then we can bring it back into the, okay. Oh, okay. So when you open that window for your skyline, there will, on the left hand side, there will be something called a targets. So just click there and just press paste, Control V, and it will paste all those molecules in that area. And that's how you can get your data inside this software.
हेलो सर,
Hmm.
एक्चुअली वो स्काईलाइन पे क्लिक करने के बाद आप जो स्क्रीन दिखा रहे हैं वो दिख नहीं रही है। एक्चुअली उसमें क्या हो रहा है कि वो जो मेन वाला है फाइल वो दिख रहा है, लेकिन आगे का जो है जनरेशन ऑफ टारगेटेड वो नहीं दिख रहा, सिर्फ टारगेट दिख रहा है। जनरेटिंग अ ट्रांजिशन वाली जो स्लाइड है ना, मेनू सेटिंग ट्रांजिशन सेटिंग, वहां से कुछ नहीं आ रहा है, सिर्फ टारगेट दिख रहा है लेफ्ट साइड
नहीं
में,
तो
राइट साइड में पूरा ब्लैंक आ रहा है।
जब आप ये सारी सेटिंग करोगे और जब उसको ओके करोगे तो वो सारी सेटिंग सेव हो गई है, फिर आपको कुछ करना नहीं है। हमें सिर्फ इस जो ये जो शीट है, एक्सेल शीट में के जो डेटा है उसको कॉपी करना है और जो टारगेट जहाँ पे लिखा हुआ है ना उस एरिया में जाके पेस्ट करना है। अगर आप
एक्चुअली
उसे
सर
पेस्ट
क्या,
करेंगे
उस वो स्काईलाइन का
हम्म,
जो डाउनलोड किया है उसके ऊपर क्लिक करने के बाद राइट साइड में ब्लैंक डॉक्यूमेंट, इंपोर्ट डीडीए पेप्टाइड सर्च, इंपोर्ट डीआई पेप्टाइड
हाँ,
सर्च, ऐसे
ओके
4-5
ओके ओके
आइकॉन आ
ओके
रहे।
ओके। हाँ, तो
हाँ
एक्चुअली क्या हो रहा है कि आपने है ना उसका जो मॉलिक्यूल इंटरफेस है उसको, अभी
हाँ,
प्रोटेमिक्स में है, उसको मॉलिक्यूल इंटरफेस में करिए।
तो वो कहाँ से आएगा?
आपके जो ब्लैंक डॉक्यूमेंट के राइट हैंड साइड में जाइए, यहाँ पर एक ऐसा मॉलिक्यूल का आइकन दिखेगा आपको, उसको क्लिक करिए माउस से।
इंपोर्ट इंपोर्ट डीडीए पेप्टाइड
इंपोर्ट
सर्च क्या?
नहीं, नहीं, जहां पर
वो
आप
नहीं है सर।
ये क्रॉस साइन है जहां से अपन क्लोज करते डॉक्यूमेंट, उसके नीचे एक छोटा सा आइकन है, उसको क्लिक करिए तो वहां पर मॉलिक्यूल इंटरफेस को सिलेक्ट करिए पहले।
मॉल हाँ, इंटरफेरेंस, मॉलिक्यूलर इंटरफेरेंस। फिर वहां पे
उसको,
ब्लैंक डॉक्यूमेंट एक आ रहा है और इंपोर्ट
हाँ,
ट्रांजिशन लिस्ट आ रहा है।
हाँ, तो सिर्फ ब्लैंक डॉक्यूमेंट को क्लिक करिए पहले।
हम्म,
ओके, जब ब्लैंक डॉक्यूमेंट को क्लिक करेंगे तो आपको फिर एक सिंपल सा ब्लैंक डॉक्यूमेंट मिलेगा। उसके बाद
एकदम
आप
ब्लैंक है।
जाइए हाँ, उसके बाद आप जाइए सेटिंग्स में, फिर चाहिए सिलेक्ट करिए ट्रांजिशन सेटिंग्स और फिर ये सारे सेटिंग्स उसमें डालिए।
हाँ हाँ, अब आ गया, थैंक यू सर। अब बाकी के
ठीक है,
स्क्रीनशॉट लेके रखी हूँ।
लेने की जरूरत नहीं है, सारे स्लाइड्स आपके लिए अवेलेबल है वहां पर, आप स्लाइड डाउनलोड करके आराम से बैठ के भी कर सकते हैं, कोई हड़बड़ी नहीं है।
ओके, ठीक है, चलेगा,
ठीक है,
थैंक यू सो मच सर। हाँ,
ठीक है, ठीक है। और उसके बाद आफ्टर दैट यू कॉपी दिस whole Excel sheet and then paste that Excel thing, that data in the target area. Click in the target area and say Control V, paste it. So it will give you a lot of different names of the molecules, and then you have to save that file with some name. Okay. So once you save that file, now our document is ready to handle or import our data, and now we can start analyzing our data. So go to the file menu, click import and select results. Okay, and then just don't make any changes, just say okay, and then it will open a window to ask for all the files. So go to the folder where you have selected, select all the files together and say open. So what this will do is that this will import all your data into that software, and then it will be ready for your visualization. Okay. Does anyone have any problem in that so far?
No, sir, it is clear.
Okay. So once all the files are loaded, what you can do is that press F7 and F8. So it will open up two more windows. One window will show you the peak area and another window will show you the retention time. You can dog them somewhere or you can leave them as it is. Depend on how you want to see the data. And now, once you get all the data, now you can go to the target area and you can click on any molecule. It will show the peak of that molecule in that file.
Where I am not able to put that Excel data into target site.
Okay, did you copy that? And you have to copy that data, Control
Yes,
C,
sir.
and then go to the
Yes.
target area and say Control V. It should copy all the data there.
पूर्ण शीट कॉपी केली आणि तिकडे पेस्ट केली पण तिथे ते मग समोरचं दाखव हे नाही दिसत आहे. मॉलिक्यूल लिस्ट अँड नेम प्रिकर्सर दाखवत आहे. मॉलिक्यूल लिस्ट नेम प्रिकर्सर
Hmm.
molecule list name precursor formula precursor, but it is not
Ah,
loading something.
नाही. This is the data which we have to copy. हा जो डेटा हा कॉपी करायचा. तर जेव्हा
ठीक आहे.
तुम्ही इथे पेस्ट कराल, इथे कॉपी
हा.
पेस्ट कराल ना, तुम्हाला फक्त नाव
हा.
दिसेल मॉलिक्युलचे, बाकी काही दिसणार नाही. आणि तिथे एक प्लस साइन असेल त्याच्या खाली, जर ते प्लस साइनला तू क्लिक केलं तर तिथे तुला बाकी इन्फॉर्मेशन दिसेल, त्याचं मास काय आहे, काय आहे, सगळं काही गोष्टी. समोर फक्त तुला फक्त नाव दिसेल मॉलिक्युलचं, बाकी काही दिसणार नाही.
Excuse me, sir.
Yeah.
Sir, I am having some problem. Actually, I was little behind because that particular software was not opening. So I am
Okay.
right now on the page where it is full scan. So then
Okay.
what is the next step?
Okay.
खाली
So
आहे.
once you
Where
have the
peaks are
full
yes.
scan, okay.
आता लगेच
Okay, I've done okay. Yes.
Okay, just do okay. And then
Okay.
open the Excel sheet, the Skyline a transition Excel sheet. Copy this whole thing. Okay.
From
And
where this Excel sheet will open, sir? Can you please guide me?
the Excel sheet is provided in the same tutorial folder where you have,
Okay.
ideally, you should have a zip file, which is targeted metabolite quantification zip file. You unzip that file. Within that file, you have all the raw data and the
Okay.
Excel sheets and everything there.
Okay. Okay, sir.
So open up that file and then copy these all these information and you paste that information in the target area of that Skyline document, which you
Okay.
have just created. Okay.
Yeah, yes. Okay. Thank you.
Okay. So I think most of the people have successfully imported their data into the Skyline software. Okay, and once you import all the data, and if you click on any molecule, it will show up the chromatogram of that molecule. So say, for example, if you click on alanine, it will show that the alanine is eluted at a particular time. So a particular time is shown here as 1.5, and the mass of that molecule is shown on the top left hand side as a precursor and some number. So that precursor and number means that is the actual mass of that molecule. Although we haven't provided any mass in our data, what we have provided here is just a molecular formula, but the software can take a molecular formula and it can determine what is the actual mass based on the molecular formula and based on the adduct information we have added. Okay, so based on these two information, it determines its accurate mass of that particular molecule. So you can see here the molecule and its mass is very accurate up to 4 digits, uh, uh, four numbers after a digit, which is very accurate. Okay, so once we finish loading all our samples and all our information, now we need to start doing all the quantification. Okay, so now we can go to the view menu and click document grid. The document grid should be almost at the bottom. Okay, once you select the document grid, a window like this will open, and then go to this reports and click it, and it says just select replicates. Okay, and within that replicate, all the samples you have, there are certain samples which has a name called as CAL111213. So these are different standards, mixture of standards, uh, and run in triplicate. So you click the sample type there. There are different types of samples provided in that drop down list. Select them as a standard, select one, and then using your mouse select all of them, and then go make a right click and say fill all. So that will select all of them as a standard, or you can do it manually individually for each molecule, for each sample. Any file which has named as a blank is a blank. Any file which is named as a double blank, select as a double blank. And after that, all those samples start from A1 to B8, make them as unknown, because these are the actual sample from our experiment, and we want to determine the concentration of our amino acids within these 16 samples. Okay, and the third column, you will have something called analyte concentration. So this is where we will put the concentration of our molecules. So you can see here we have calibrant 1, which is 10 micromolar, calibrant 2 is 5 micromolar, calibrant 3 is 1 micromolar, and so on and so forth. So you need to type in this information in that text box.
नेहा नेहा दीदी, वो नीचे के ब्राउन कलर का बॉक्स है ना, उसमें है चाबी। नीचे में ब्राउन कलर का बॉक्स है ना, उसमें चावी है। ते ब्राउन कलरचा बॉक्स आहे ना, त्याच्यामध्ये चावी आहे, ती देऊन द्या बरं म्हणून त्याला।
Okay, does everyone up to the mark, up to here now, or someone is lagging behind?
नीचे में वो आया पॉपुलर लेते ना।
Can we wait a few minutes, sir? My data is getting imported into the
Okay,
software
okay,
right
okay,
now.
okay. Yeah, it's fine. I mean, if
Mm.
someone is lagging behind, just
Mm.
just let us know. We can wait. And if people have already done with this part, like defining their samples, define the sample part, then they can go ahead with the next part, which just again go to settings. Now this time go to molecule settings and go to the, if you click molecule setting, it will open a window like this, and straight away go to quantification tab, and then select all these settings. As a linear regression fit is linear, regression weighing is 1 by x, or you can just leave the regression weighing as none, ms level as all, unit, because the concentration of our standards are in micromolar, so we will write micromolar here. And we can also determine something called as LOD and LOQ. So LOD is the minimum level of detection, which is called as LOD is called as minimum level of detection. So minimum concentration of detect any molecule we can detect within that system. It is called as LOD, and LOQ is something called as minimum how much you can quantify. Okay, so we can determine all these things using this software as well. So you can fill in all the information as shown in this screenshot. Okay, so once we are done with that, then we can actually look at our concentration curve. So to look at the concentration curve, just go to the view menu, click calibration curve. It will open up a window, and then when you select any molecule, it will show the standard curve of that molecule. And you might get a figure something like that. Hate sir, you don't have to zip the file, you have to unzip the file. There, because in that folder we have multiple files. That's why I've इसीलिए मैंने आपको बताया था कि पहले वो जो WinZip नाम का सॉफ्टवेयर है उसको डाउनलोड करिए. उसको करने के बाद you should be able to easily open that file and open all the information. Okay, so can anyone tell me, does anyone have this calibration curve on their experiment?
नो सर, नाही आलं.
नाही आलं. ओके, काय प्रॉब्लेम आहे? Okay, I think few people might have problem, but I think most of the people have already done this, looks like. So we can move forward to the next slide. So once we have
Excuse me,
this
sir.
standard curve, hello,
So which analyte we have to select for calibration curve?
you can select any analyte. Once you select the analyte,
Okay.
you should be able to see a calibration curve like this. Just click on any molecule in that target list. It will show
Okay.
the calibration curve for that particular molecule.
Yes.
दिख रहा है?
Okay. Okay. Yes, sir.
Okay. So what exactly this particular figure is showing that these are the different concentration of samples standards we have run together, and it's showing their data points here, right from 10 micromolar to 5 micromolar to 1 micromolar and so on and so forth. And it also showing that how linear those data points are, and the linearity of data point is measured using something called as R square. So the more R square is closer to 1, which shows that your data points are very linear. And that's what we strive to achieve, to get a linear data point so that it will give us a one-to-one relationship with your unknown sample. So say for example, now from one of your sample, if your concentration of that sample fall between these two data points, okay, if your concentration fall between maybe here, now if you draw a perpendicular here and here, using that area you can determine what is the exact concentration of your sample. And basically this whole formula does the same thing what I'm showing you here. And you can try clicking different molecules and it will give you a standard curve for each molecule. Again, after you get the standard curve, if you again go to the view menu in document grid, and then if you click on maybe you will not have a bile acid quant column there, but you will have something called as peptide report or molecule report. If you click that, you will get a data like this where you have all the concentration, analyte concentration, and finally there will be a column which shows the actual concentration of your unknown samples. So, something like this calculated concentration. Okay, so maybe go to the reports and click peptide quantification. So once you click the peptide quantification, it will open up a window like this, and which shows the calculated concentration of your known and unknown samples. And you can export this data as in Excel. Just click export button, and you can export that data as a CSV file, and then you can open it in Excel. And finally, if you want to create your own customized report, like
Okay.
if you don't like the way this data is presented here, if you want to make something different, then you have to go to this report menu, click down, go to peptide quantification. It will show you a standard format of the report, and then we can modify that report. Okay, to modify that report, you have to go to this edit report button, click it, and then we can add some more different things in our report, whether you want to add peak area, total peak area, calibration curve information, r square values, and whatnot. So you can add all those components in your report and click OK. So your report will have all these components. Then you can export into Excel. And once you export in Excel, in the end, you can plot your data, which shows that how the, the toxin which was produced by this bacteria Pseudomonas syringae has affected the amino acid metabolism. You can see here, in this case, asparagine is reduced by the activity of drug, histidine is reduced by the activity of glycine is reduced by the activity of drug, whereas glutamic acid is increased, leucine is reduced, serine is reduced, and so on and so forth. And all the values you will get are absolute values in terms of micromolar concentration.
Hello, sir.
Hmm.
Sir, last slide where we click on that particular. I have not get it.
Here,
The last
here,
slide.
here,
Huh.
here.
Yes.
Okay, so
Yes, sir.
you on the top we have something as binocular. Can you see that
Yes, sir.
binocular icon? Okay, so click that binocular icon, and then you can type different things like total area or limit or calibration curve. So this is basically a search function. So whenever you click something in that binocular icon, it will search for that term in this menu, and then you can select that menu and add that menu in your report. So what we are doing is we are adding multiple components to our report. Okay, and finally we
Means
can say
by
okay, and then we
simply
can
by simply clicking on that, we are adding that particular molecule in
no
that
no
in
no
the report.
no. You have to
Then
click the binocular first, and then you have to write something in the text area. If you write total area in the text area, then you will get some results, and where you will find something called total area, you need to click that check mark. If you click that check mark, the total area will be added in the right hand side panel. So that's how you have to build your report.
okay, sir.
So once you get your data in Excel, then you can plot it, do statistical analysis on it, put error bars on it, and whatnot. Okay, anyone have any problem so far? At least can everyone get their data out in Excel after doing this whole exercise? तुम्हाला काही प्रॉब्लेम असला तर सांगा मला.
Hello, sir. Sir, sir, can you please rewind the slides, sir, one by one, so that because
Here?
and it will be back, sir. That's why I can't get the report. So my net is very slow. That's why I can't able to.
Okay. No, it's fine. I mean,
It will.
as long as you follow along, because you have all the slides in that same folder, so you can practice this exercise at your own time, at your own pace. So don't worry about that.
ओके सर। हेलो सर, सॉरी बट वो स्टार्टिंग से ही नहीं हुआ, वो टारगेटेड के बाद जो भी स्लाइड में दिखाई दे रहा है, तो हमारे यहाँ जो ओपन होते हैं ऑप्शन, जैसे कि फुल स्क्रीन में, तो जो एमएस फिल्टरिंग वगैरह है, तो आपके यहाँ के जो स्लाइड में शो किए हैं वो अलग ऑप्शन दिखा रहे हैं, हमारे यहाँ अलग दिखा रहे हैं, तो वही स्टार्टिंग से ही नहीं
नहीं,
हो पा रहा है।
ऐसा नहीं हो सकता है, क्योंकि अगर आप मेनू में सेटिंग में जाकर ट्रांजिशन सेटिंग अगर क्लिक करेंगे तो आपको यही दिखेगा।
सेटिंग में जाने के बाद
हम्म,
ट्रांजिशन सेटिंग आया, उसके बाद जैसे कि फुल स्क्रीन है, तो फुल स्क्रीन के जैसे कि आपके स्लाइड में जो ऑप्शन दिखा रहे हैं,
हम्म,
वो अब मैं आपको
फुल स्क्रीन
बताती
कहाँ
हूँ
पे?
कि जैसे कि आईसो सेटिंग में जाने के बाद ट्रांजिशन सेटिंग आती है, उसमें प्रेडिक्शन, फिल्टर, लाइब्रेरी, इंस्ट्रूमेंट, उसमें जो फुल स्क्रीन है आइसोटोप पिक इन इंक्लूड, वहां पे काउंट आता है, लेकिन
हाँ,
जो प्रिकर्सर मास एनालाइजर है, यहाँ पे जो भी
हाँ,
मेरे ऑप्शन दिखाई देते हैं, वहां पे
हम्म,
सेंट्रॉइडेड, क्यूआईटी, टीओएफ, ऑर्बिट्रॉफ एंड एफटीआईसीआर दिखा रहा है, और आपने
हाँ,
जो सिलेक्ट किया है।
ऑर्बिट ऐप है।
हाँ हेलो सर।
और क्या सिलेक्ट किया है
हाँ,
मैंने?
और उसके बाद
एक्चुअली ये
टारगेट।
जो और जो मास एनालाइजर है, ये डिपेंड करता है कि आप
हाँ,
कौन सा इंस्ट्रूमेंट यूज कर रहे हैं। Okay, so
ओके,
based on that
हाँ,
instrument, you have to select what instrument or what mass analyzer you have used. So in
वो
this,
जो
for this
एटोस्टिशियन
instrument,
मेथड है ना, उसमें आपने
हम्म,
टारगेटेड सिलेक्ट किया है, लेकिन यहाँ पे टारगेटेड आता ही नहीं है, DIA
हाँ तो मैं
PIM DD।
हाँ तो मैं आपको वही, जब उस कंडीशन पे आया तो मैंने बताया था कि जो स्लाइड्स जो बनाई है वो पुराने वर्जन के लेकर बनाई हुई है। तो इसमें क्या हुआ है कि टारगेटेड की जगह उन्होंने वहां पे नया टर्म यूज किया है, विच इज कॉल्ड एज PRM। So use that
हाँ,
PRM, select PRM.
PRM सिलेक्ट।
Okay, and again in the mass analyzer, select orbit trap.
हाँ,
Put 30,000 and 200 and then click OK.
60,000 आया है यहाँ पे, उसमें 30,000 लेना।
हाँ, क्योंकि ये MS1 फिल्टरिंग, ये फुल स्कैन मोड है, उसमें रेजोल्यूशन ज्यादा रहता है, और जब हम उसको तोड़ते हैं उसका रेजोल्यूशन कम होता है।
तो फिर उसके बाद ओके करने के बाद फिर ब्लैंक ही आता है।
हाँ तो वो हो गया, यहाँ सिर्फ सेटिंग करना है हमको। जब सारा सेटिंग हो जाएगा,
हाँ,
उसके बाद हमें जो
हाँ,
एक्सेल शीट अब मैंने आपको प्रोवाइड की है, यू ओपन दिस एक्सेल शीट, कॉपी ऑल दिस डेटा, कंट्रोल C
तो
एंड
सर
गो टू दिस
लेना
डॉक्यूमेंट।
पड़ेगा
ये जो फाइल है, जो फोल्डर आपको
फाइल।
दिया गया था, जो उसमें जिप फाइल थी, वो उसके अंदर सारे फाइल्स, रॉ फाइल्स हैं, साथ में ये फाइल भी उसके अंदर है।
तो वो जिप फाइल भी डाउनलोड करने की कोशिश की, लेकिन वो जिप फाइल कहाँ डाउनलोड नहीं हो रहा है, मतलब।
जिप फाइल डाउनलोड हुई आपकी, लेकिन वो खुल नहीं रही है, क्योंकि आपने उसको खोलने के लिए सॉफ्टवेयर लगता है, वो आपके पास शायद होगा नहीं। So what you need to do is that download WinZip, something called as WinZip or WinRAR. Okay. Once you have that
हाँ,
software, then you can open it.
लेकिन सर वो कहाँ पे ओपन होगा, फाइल में, एडिट में, व्यू में, सेटिंग में, कहाँ पे होगा? यहाँ पे आएगा ऊपर आइकॉन में।
क्या ओपन होगा?
मैडम आपने जिप
सर
फाइल ओपन, आपकी जिप फाइल जो डाउनलोड हुई है ना, वो आपके सिस्टम के डाउनलोड्स में आपको मिलेगी। वहां से आप राइट क्लिक करके फाइल एक्सट्रैक्ट करिए एक फोल्डर में, तब वो सारी फाइल्स आ जाएगी जो भी सर ने भेजी है। वो जिप फोल्डर में से फाइल को एक्सट्रैक्ट करिए।
ठीक है,
यस सर, यू कैन प्रोसीड।
चलेगा, ठीक है।
Okay.
Sir, just a minute. Hello.
Hmm. Hmm.
Do we need to copy whole file, sir?
Like this one?
Excel, yes.
No, just open that file and select the whole thing, right from column 1 to column E.
Okay.
Select everything, copy, just say Control C, and then go to this blank document in the target area and press Control V. So what that
Okay.
will do, it will take all the information from your Excel sheet and copy it in your document. And although you will not see anything there, it will just show names of that molecule. But
Okay.
if you see the name of the molecule, it means that everything is already there. Then you can save your file. and then you can start importing your data. So go to the import, in the file menu, go to import, select results, say OK, and then go to the folder where we have all these raw files, the targeted metabolic quantification folder. Select all the files. Okay, it will ask, because all the file have some common phrase. It will ask you, do you want to remove that common phrase? If you want it, you can keep it. If you don't want it, you can remove it. Okay, and then it will start loading those files in that software. You will see a green progress bar there. Okay, once everything is loaded, if you click any one of these molecule in the target window, it will show you a peak like this. यहाँ तक आ गए संदीप?
Yes, sir.
कठिन.
Excuse me, sir.
Hmm.
I have generated the calibration curve, but after
Hmm.
that, in the grade menu, I am not getting the option of quantification of peptides. Uh, in the
Quantification of
report
peptide. And
section,
okay,
there's
okay, रिपोर्ट सेक्शन. हाँ, तो जरूरी नहीं है,
वहाँ
शायद
हाँ
क्योंकि
हाँ
ये पुराना वर्जन
हाँ
था, तो आपके इसमें शायद कोई
हम्म,
दूसरा आया होगा. जस्ट ट्राई टू लुक
हाँ,
फॉर समथिंग क्वांटिफिकेशन. ओके,
वहाँ
इफ यू
है
हैव
सर, एक
समथिंग.
मॉलिक्यूलर क्वांटिफिकेशन है, एक
हाँ,
ऑप्शन
तो
मैंने
जस्ट
सिलेक्ट
क्लिक
किया
दैट.
उसे, तो
जस्ट
उसमें हाँ
जस्ट
हाँ
तो उसमें
क्लिक
आपको
करने के बाद
मल्टीपल कॉलम्स
हाँ
आएंगे, उसमें कैलिब्रेशन कर्व आएगा, रेप्लिकेट आएगा, उसमें आपको कैलकुलेट कॉन्सेंट्रेशन भी आएगा. सो दिस कॉलम विल शो what is the concentration of your unknown, of the molecule from your unknown sample.
हाँ सर, टेबुलर फॉर्मेट में आए हैं शीट, बट उसमें जो है वो ब्लैंक है सभी चीजें,
Calculate concentration.
मतलब हाँ कैलकुलेटेड कॉन्सेंट्रेशन नहीं दिया है उसमें.
ओके, वो इसलिए दिया नहीं है क्योंकि तुमने उसको क्वांटिफिकेशन ठीक से किया नहीं होगा. सो गो बैक टू, अगेन टू सेटिंग्स, क्लिक मॉलिक्यूल सेटिंग्स, and
यस सर.
when you click call molecule setting, it will open this kind of a screen. Then go to quantification tab.
यस
In
सर.
the regression fit, select linear. Okay,
यस सर.
then don't then
यस.
either you can, for regression weighing, you can make 1 by x or just leave it as it is, none. For ms level, select all
ओके. यस.
and calculate LOD by blank plus 3 times standard deviation and click OK. Now if you click any molecule in the window, you will see a standard curve like this. आया?
हाँ कैलिब्रेशन का शो कर रहा है.
Hmm. Okay. So basically, you created a report, and then you can export that data out, and then you can plot it in Excel or any other software, Jump or Orion or any other software. Okay, I think everyone has the data and the whole slides and everything. Maybe you can try at your own pace and at your own time, and try to learn this software. If you want, you can download more files from some public repositories. I'll give name of that repository, and then you can practice as well at home. Okay, questions. Does anyone have any questions now?
Participants, if you have any question, please ask. Nishikant sir, can you share your number in the chat box?
Yeah.
So can you get video of this recorded video of this session?
Yes, madam, मीटिंग इज रिकॉर्डिंग. आपको मैं भेज दूंगी.
Okay.
जैसे अपने सारे सेशंस रिकॉर्ड हो रहे हैं, ये सेशन भी रिकॉर्ड हो रहा है.
Okay. So that is my number.
Yes.
Actually, sir, I was also not able to complete that assignment. So I'll see the video and then I'll try to attempt it, sir.
Yeah, you can see the video, and I think the PowerPoint presentation is already there in that same folder. So
Yes,
you
yes.
you can open that PowerPoint file, and then and all the instructions which we see here in the talk will be there. So you can
Okay.
follow that instructions as well, and you can learn.
Okay, sir. Thank you.
Yeah. I hope I teach you guys something useful today. I don't know how much useful that could be.
No,
Excuse
sir,
me,
it's
sir.
very much useful for us, sir.
Hello, sir.
Hmm.
Sir, for the generation of raw data, we have to use the MSMS or we can generally use LCMS for such type of metabolomic study.
LCMS. Yes, we can use LCMS. That's right. We can use
क्योंकि
LCMS.
सर उसमें
Uh,
सॉफ्ट
and
आयनाइजेशन की वजह से उतने ज्यादा अच्छे से फ्रेगमेंटेशन नहीं होता है सिर्फ अगर LCMS यूज करते हैं तो मतलब फिर
so
भी हम
that
लोग
is the
कर
whole
सकते हैं
point.
क्या
That is
उसको?
the whole
हाँ,
point of using a
हाँ,
soft ionization, because soft ionization do not destroy your molecule completely. What it does is that
okay.
wherever you have weaker bonds, say for example, in any molecule, when there is a carbon-carbon bond or when there is a carbon-nitrogen bond, so what you will have is a sigma bond and pi bond. So as we know, the sigma bond is more stable than a pi bond. So first, in any complex molecule or in any natural product or in any biological molecule, wherever we have a pi bond or a coordinate covalent bond, that will break first because of the soft ionization. And that, what that will do is that it will give you maybe two or three fragments which we can predict where it will break, and based on that, then we can predict and determine the whole structure. But if we use harsh fragmentation method, like uh, high energy impact ionization, it will break that molecule into several pieces, and it's difficult to put it back together. So it's
Okay.
something like this. If you have a cup, china clay cup, if you drop it from 10 feet on ground, it will shatter into maybe 50 pieces. But if you drop that same cup from 1 feet, maybe that cup will break into four pieces. But those four pieces, you can put it together and you can bring that structure back and you can understand that structure. But the cup which you drop from 50 feet and which shattered into maybe 50 pieces, that's very difficult to put it back together. So that's exactly what we are doing here. We are just doing soft ionization. We are fragmenting it in a such a way that later on we can put that whole structure back and we can understand that molecule. Does that answer your question?
Yes, sir. And for the targeted study, we have to do the external calibration for all the molecules we are interested in.
Yeah, you can do external calibration. So there are two strategies basically people are using. Number one is either you can spike an internal standard. So that's what I was talking about. Uh,
Yes.
Using heavy labeled compounds. Okay. So what the heavy label compound will do is that You can see here we have asparagine, which is light, which is present in our sample, and then we add heavy labeled asparagine into the sample, and the concentration of this heavy labeled asparagine is known to us. So what would happen is that if you take a ratio of light versus heavy, okay, and if the ratio
Yes, sir.
come very close to 1, which means that the the amount of asparagine in our unknown sample is at least 10 micrograms, because we have spike in 10 micrograms of heavy label standard in the mixture. Does that uh, make sense now?
Yes, sir.
Hello, sir.
Hmm.
Sir, I have a query. After doing the transition setting, the very
Hmm.
next step is to create an Excel sheet. But in the today's
You
case,
don't
you
have
have
to.
already
You don't have to. You don't have to create Excel sheet. I have already provided an Excel sheet.
that is in the today's case. But suppose
Hmm.
if I'm performing that experiment, so
Hmm.
I have to prepare that Excel sheet manually.
Yes, you have to prepare the Excel sheet manually. So either see, you don't have to prepare the whole thing manually. You can enter single molecule um, uh, in that in that software as well. So if you go to uh, edit menu, if you go to edit menu,
Hmm.
toward the end you will have something called as insert transitions. If you click
Okay.
that, then it will open a window, and then you have to type everything there. And if you make any mistake, it will start giving you error. So it's better to do that in Excel, where you know where you can make mistake, you can change it quickly, and you can copy the whole thing together and then put it back like copy and paste. That's the benefit of doing it this way.
But my if my study is dealing with a particular precursor like cysteine, so I have to
Hmm.
select only that particular name cysteine.
Yeah,
No. Okay.
yeah, but even if you try to select particular system, but this whatever header we have in the row number 1, they should be there. If you don't have the header, that software can't recognize that data. Okay, so make
Okay.
sure that you should have these header or the uh, column titles, and then you can add anything, or maybe you can put a filter and remove everything, just keep 16, then do a copy paste, and it will just take 16. Or
Okay.
either way, you copy this whole thing, put it back in your Skyline document, then delete everything except for the your molecule of interest.
Okay, sir.
Excuse me, sir.
Hmm.
Hello.
Uh-huh.
Sir, I have a questions.
Hmm.
Sir, if I'm interested in the metabolome related with the lipids,
Hmm.
so as we do derivatization in the for performing the GCMS of the lipids, so
Hmm.
do we require derivatization even in the LCMS?
No, I mean, in LCMS, in some condition, it might require, but normally we don't need any derivatization. And the reason why we do derivatization in GCMS is that because GCMS is a technique where you take this mixture of molecules, or mixture your mixture matrix, complex matrix.
Hmm.
Okay, and what we actually try to do is that we convert everything into gas phase.
Hmm.
Okay, but the
Right,
thing is that in a complex mixture, not all molecules are volatile.
right.
So to make them volatile, then we use a derivatizing agent such as MSTFA or BSTFA. So
Yes.
what the derivatizing agent will do basically is that it try to look for any molecule with a carboxyl group, or hydroxyl group, or keto group, and then it attach the silation molecule to that group, and the silation molecule make it more volatile. And the
Hmm.
more volatile that compound is, it's easier for the mass spectrometer to convert it to gas phase and detect it. So that's the whole purpose of doing derivatization in GCMS.
Right, sir. Hello.
Hello.
Sir, you again one more question. You said that the heavy labeled molecule, use of heavy labeled molecule for the analysis or the quantification is a gold standard. But
Yes.
in India, do we have a better source for the heavy label molecule? Do you have any idea on this?
It's not about in India because heavy labeled molecule, buying heavy labeled molecule is
Yes,
very expensive.
right.
That's why if you want to do an absolutely perfect experiment, you have to
Mm,
use heavy labeled molecule. But if you want to just like finish your experiment and do at
mm,
a reasonable quality and a reasonable price,
mm.
then you can do using external standard
Okay.
calibration curve. Okay, so those are the two approaches we can use.
So, is there any kind of repositories for the standard data available?
Repository, yes, there is something called as,
So we can use that for our molecules if we are interested in that molecule, particular molecule.
so this is a repository called as metabolomics workbench. So you can
Okay, sir.
visit on this repository, and it's a publicly available repository. You can download any data which is available there, and if you go to this repository, you will see lot of interesting projects, lot of interesting studies, and the data is freely available for you to work and analyze the data. So this is one repository. The second repository is, second. The second repository is this one. So you can go to head over to this repository. The downloading that data is little bit problematic. You can't download the data directly. What you need to do is that you have to install a software called as FTP software. Okay, and
FTQ,
using that FTP, yeah, FTP software.
FTP. Okay.
So there are few freely available FTP software such as or FileZilla. So you can search for these terms, Qt, FTP, or FileZilla. Download
Hmm,
that software, and when you search for any interesting project, say for example, if you want to search a project on cancer,
hmm.
if you search for a project on cancer, okay, there are 91 projects available there uh, on this repository. Okay, so you
Sir,
can
are you
click any
trying to
study.
showing your screen, your search
Oh,
screen?
can you see my screen?
No, no, sir, no.
Okay, hang on a second.
I just noted down whatever you said, sir.
Okay, hang on a second.
Okay, sir.
Stop sharing this and share. Okay, share the screen. Okay, so I think now you can see
Yes,
that.
sir.
Okay,
Yes, right, sir.
so you go to metabolomics workbench
Hmm,
and then search for maybe just put a term called cancer, and you
hmm,
will get a list of projects. It says 91 projects are available there related to cancer, and
okay.
if you want to take any one of these project,
Hmm,
click that, and in this project, if you want to download those files, So you can see here the total size of that file is like 51 gigabytes.
Okay.
Okay, and this is where it gives you all the information how you can download this all these files from this repository. Okay,
Okay.
and then you
Yes.
can take these files and you can analyze on your own, and you can understand how things are changing in that particular project. Or sometimes they also provide the name of the paper where the study was used, so you can use that information and study it.
Right. Sir.
Okay, anything else?
Okay, sir. I will
Any more
go.
questions?
Yes, sir. I have last question, sir.
Hmm.
Sir, you told us about the fragmentation pattern, right?
Hmm.
And you said that in the tandem mass spectra,
Hmm.
the highest peak or the highest value over the peak represent the entire molecular weight of the molecule.
Yeah, that's your precursor ion.
Yes,
But
and
but
the next
no,
slide, sir.
yeah.
Right here.
Hmm.
So you said that the first peak here from the right side is 133 point something. Okay.
Yeah, so that's your precursor ion.
Okay, so this is the sequence of the peak showing here. That is, first peak belongs to the fragmentation of the ammonia group. Second
Yeah,
peak, that is 116, the carboxyl group. So
yeah.
this sequence of the peaks represents the sequence of the fragmentation, or just it is just random.
It is random.
Okay,
Okay, it's random. But the peaks will appear based on its molecular mass. Okay, the lower the molecular mass, you will get the peak earlier. If the molecular mass is higher or close to your precursor ion, it will shown as later. Okay,
okay,
so say for example, this 74, because it was lower in mass, it it's shown earlier.
right. So I have read in the various research paper, if there is unknown compound, so on the
Hmm.
basis of these peaks,
Hmm.
they determine what will be the probable compound. So is there any
Yeah,
tool to use the similar technique?
there are some tools, but the thing is that this is where things get difficult, and that's
Right.
why you need an experienced eyes of an analytical chemist.
Right.
Not everything is done in software.
Right.
Not everything is done in software, and that's why you need to sit for hours and hours looking through this spectra. It's a back-breaking work.
Okay. Fine, sir. Thank you, sir.
Any more questions?
Okay.
Okay, sir. I think there are no questions now.
Okay, then, yeah, I
Yes.
think everyone is exhausted for with today's session, looks like.
Sir, it needs practice actually.
Yeah, I know it need practice. I
Yes.
mean,
Yes,
even
sir.
after working on these things for last 6 7 years, there are times when I have to scratch my head that इसको
Yes.
कैसे करूँ अभी. So it's normal.
Sir, but at least you have shown us the glimpses of that, so we can do it later also after
Yeah, I
practicing
think
that. Yes.
that was the whole idea when I talked with Dongarwasa. I said, well,
Yes, sir.
thing is that lot of time we just read this about these things in books,
Hmm.
in a research paper, but we
Research
never
paper.
had that experience of taking that actual data and analyzing it and see how it looks like and what we can learn from it.
Yes, sir. Very
So
true.
that was the whole idea of doing this kind of a workshop thing.
Yes, sir. But it was a nice session, sir.
Okay, well,
So
thank you very much.
thank you,
I
sir.
hope people have liked it,
Yes, sir. Yes.
and they get something new, some kind of new flavor on their experience.
And it will be very beneficial for publishing a high impact journal research papers.
Yeah, definitely,
Yeah. Yes,
definitely.
sir. Yes. So now I
Not taking a
request,
lot of.
Mhm.
any question?
No, ma'am. No
Yeah.
question.
Yes.
Okay, and I think all the materials are already in that folder, so you can try this thing over in at home and just practice it. That's what uh, make it more fun. Okay.
Yes, sir. Yes. So now I request
sir.
Dr. Sandeep Hate, sir. Sandeep, sir, are you there?
Yes, ma'am. I am here.
Yes. Kindly proceed.
Yeah, am I audible?
Yes.
या बिल्कुल सुन सकते
Okay.
संदीप जी, बोलिए.
Yes, sir. Very good morning to all of you. Myself, Dr. Sandeep Hate. I would like to express my sincere thanks to Dr. Nishikant Wase, sir, for his wonderful and very informative session. Now, on behalf of HRDC, UGC, and Rashtra Sant Tukaji Maharaj Nagpur University, Nagpur, as well as all the participants, sir, you touch us. So you teach us so many things today, and I assure you that we all will try for our best to do in our future. Okay. Thank you so much,
Okay,
sir, for such a
thank you very much.
nice
Yeah,
lecture. Thank you, sir.
at least few people from this audience can use these things in their own work. That's all make it all worthwhile for me.
Yes, sir.
Definitely, sir.
Definitely.
Yes, sir,
Definitely, sir.
Thank you
definitely.
very much.
Yes.
Thank you very much from my side that you all sit there patiently and listen to all the blabbering I have about these things. Thank you very much.
Thank you. Thank you once again, sir.
Thank
Thank you
you.
so much.
Thank you, Preeti
Yes,
madam.
sir.
Thank you so
Thank
much.
you. Thank you, all of you.
चलिए,
Thank you
bye.
so much, sir.
Bye, sir.
Thank you,
Yeah,
sir.
Have a nice day. Thank you, sir.
Thank you.
yeah.
Sir, this time we were not knowing ABC of this, but today we came to know.
Right, sir.
थैंक यू ऑल ऑफ यू. यहाँ पे रुकते हैं. नेक्स्ट सेशन अपना 1:30 बजे से शुरू होगा. आप आज जिनोमियो के साइट पे देखिएगा. आज आपने गूगल एप्लीकेशन शुरू किए हैं, बेसिक से स्टार्ट किया है, क्योंकि एडवांस पार्ट आपको रिसोर्स पर्सन जो आपने कल बताया था आपको आईसीटी का पार्ट चाहिए, तो अपना कमिंग वीक में 2 सेशंस आई हैव प्लान्ड फॉर एडवांस गूगल एप्लीकेशन एंड इट्स एड ऑन. आज जो आपको असाइनमेंट्स और बाकी की चीज़ें हैं दैट इज ऑन द बेसिक्स ऑफ गूगल एप्लीकेशंस. So there are 2 assignments, 1 quiz and 1 report submission. आज का सैटरडे है, टुमारो विल बी हॉलीडे, तो ये जो आज का पूरा टास्क है आप कल शाम तक भी कंप्लीट कर सकते हैं. Along with that, you have to start your preparation for seminars. After a short while, I will upload seminar timetable. ठीक है, तो आपके पास अभी बहुत सारा टास्क है परफॉर्म करने के लिए. सेमिनार का प्रिपरेशन करिए, रिपोर्ट सबमिट करना है, आज के 2 असाइनमेंट्स है और एक क्विज है. ये पूरा मिला के आपको कल शाम तक सारी चीज़ें कंप्लीट करनी है. आज के असाइनमेंट्स भी आज की डेट नहीं है फाइनल, आप उसको कल इवनिंग तक भी कंप्लीट कर सकते हैं. कल की छुट्टी है इसलिए. ठीक है, तो अच्छे से
मैडम,
परफॉर्म करिए.
हेलो मैडम,
जी,
उसमें ना डेट 10 सितंबर दिखा रहा है.